In the previous module, you've learned about views, inline table-valued functions, derived tables, and common table expressions, how to create them, and how to use them in your queries. In this lesson, you will learn about set operators. You will learn how to write queries that combine data using the union operator, how to write queries that compare sets using the intersect and except operators, how to write queries that manipulate rows in a table by using apply with the result of a derived table or a function. First, let's see how to use the union operator to combine multiple input sets into a single result. Union and union all provide a mechanism to add one set to another, allowing you to stack result sets. Union combines rows just like a join that combines columns from different sources. In this lesson, you will learn the conditions necessary to interact between input sets, how to write queries that use union to combine input sets, how to write queries that use union all to combine input sets. SQL Server provides a number of set manipulation techniques using a variety of set operators. Each input set is the result of a query which may include any select statement component you've already learned about, with the exception of an order by clause. And the result of the two input queries can then be further manipulated using any of the set operators. Sets can be combined, compared, or operated against each other using each of these set operators. And once we have the input sets, both sets must have the same number of columns, and the columns must have compatible data types. If the column data types are not initially compatible, they must be made compatible using implicit conversion. Previously in this course, we've learned that a null is not equal to anything. But in sets, a null is treated as equal to another null in a different set. And each of these set operators can be thought of having two forms, distinct and all. For example, union distinct eliminates duplicate rows while combining two sets, and union all combines all rows including duplicates. When working with set operators, it may be useful to remember that in set theory, a set does not provide a sort order, and it includes only distinct rows. If you need the results sorted, you will need to add an order by clause to the final results, since you cannot use it inside the input queries. Now let's see how to use the set operators. You can have two select statements and use the set operator in between to combine data of the two different sets, and then use the order by clause to sort the result set. Now let's see how to use the union operator. The union operator allows you to combine rows from one input set with rows from another input set into a resulting set. If a row appears in either of the input sets, it will be returned in the output. Like we discussed earlier, set operators can conceptually be thought of in two forms, distinct and all. SQL Server 2012 does not implement an explicit union distinct, though it does implement union all. In T-SQL, the use of distinct is not supported. However, it is the implicit default. So when you say union, it actually means union distinct. So when you use a union, it combines all rows from each input set and then filters out duplicate rows. From a performance standpoint, the use of union will include a filter operation whether or not there are duplicate rows. So if you need to combine sets and already know that there are no duplicates, consider using union all instead of union so that you can save the overhead of the distinct filter. Let's take a look at this example. We are combining data of country, region, and city from HR employees and the sales customers table. And only distinct rows from both the queries are written if you use union. Let's execute these queries individually and then use the union operator to combine the result set and see what the results will look like. Let's open a new query and paste the query that we just saw. And let's execute the first query by itself. And it returns 9 rows. And if you execute the second query by itself, it returns 91 rows. So when you simply combine all the rows from each set, it should yield 9 plus 91, which is 100 rows. Let's execute the union operator on both these queries and see how many rows will be returned. Click on Execute, and it returned only 71 rows because of the duplicates, which means that the union operator took the datasets from both these queries, combined them, and then filtered out the duplicate rows. When you're using these set operators, you also need to remember that there is no sort order guarantee. The results might appear to be sorted, but this is a byproduct of the filtering performed and is not assured. You need to add an order by clause at the end of the second query if you need the result set to be sorted. Let's add the order by clause, and let's order it by country and then the city. Click on Execute, and the results are sorted by country and then the city. Now let's see how to use the union all operator. You can use the union all operator if you want to return all the rows from both input sets, or if you know that there will be no duplicates to filter out, you can use the union all operator. In this example here, it will return all the country, region, and cities from both HR employees and the sales customers tables. Let's execute this query and see what the results will look like. Let's change the union operator to union all and execute the query. Click on Execute, and it returns 100 rows and also has some duplicates in the result set. The 100 rows are 9 rows from the HR employees table and 91 rows from the sales customers table. Since union all does not perform any filtering of duplicates, it can be used in place of union in cases where you know there will be no duplicate input rows and wish to improve performance compared to using union. Now that we have seen how to combine data using union and union all, in the next lesson we will see how to use except and intersect operators. In the previous lesson, you've learned how to use union and union all to combine all rows from input sets, but there may be some scenarios where you need to return either only those rows in one set but not in the other, or only rows that are present in both sets. For these purposes, the except and intersect operators may be useful to your queries. In this lesson, you will learn how to write queries that use the intersect operator to return only rows that are present in both sets, and how to write queries that use the except operator to return only rows in one set but not another. First, let's see how to use the intersect operator. The T-SQL intersect operator has been added in SQL Server 2005, and it returns only distinct rows that appear in both input sets. While union supports both conceptual forms distinct and all, intersect currently only provides an implicit distinct option. No duplicate rows will be returned by this operation. In this example, the query uses intersect to return country, city, and region information from both the HR employees and the sales customers tables. And since we are using the intersect operator, the resulting set will only return rows that are common between the HR employees and the sales customers table. Let's execute this query and see what the results will look like. Let's change the union all operator to intersect and execute the query. Click on Execute, and it will return only those rows that are existing in both the HR employees and the sales customers table. Now let's see how to use the except operator. The T-SQL except operator, which is added in SQL Server 2005, returns only distinct rows that appear in one set and not the other. To be more specific, the except operator returns rows from the input set listed first in the query. And as with queries that use a left outer join, the order in which the inputs are listed is important when you're using the except operator. While union supports both conceptual forms of distinct and all, the except operator currently only provides an implicit distinct option, just like the intersect operator. And since distinct is the only option that is provided by the except operator, no duplicate rows will be returned by the operation. In this example, it uses the except operator to return the geographical information that is not common between the employees and the customers table. And the result set from this query returns all the rows from the employees table except those that are found in the customers table. Let's execute this query and see what the results will look like. Let's change the INTERSECT operator to except and see what the results will look like. Click on execute and it will return the country, region and city information from the HR employees table and those that are not found in the customers table. Now let's change the order of tables that are used in this query and see what the results will look like. Let's change the HR employees to sales.customers and sales.customers to HR employees table. Click on execute and the returning results are different from what we saw earlier. So in this case, the first query is executed and it returns country, region and city from sales customers table, and then all the rows that have country, region and city information in the HR employees table that are similar to the sales customers table are removed from the result set. So, it is important to plan the order of tables when using the except operator. Now that we have seen how to use except and intersect operators, let's learn how to use the apply operator in the next lesson.